Okay, so Assalamualaikum and a very good morning. My name is Muhammad Nabil and I will start our presentation for group project of Thermodynamics. This project is part of course of TAM 23403 Thermodynamics, where we were required to organize and conduct an academic visit to energy related industry. Through this project, we aim to connect the theoretical concept of thermodynamics that we learn in class with real industrial application. In this presentation, we will share our experience, observation, and findings from the academic visit, including how thermodynamics principles are applied in actual industrial operation. Okay, so this is my group member, and my name is Muhammad Nabi bin Mat Zaini. And there we have our friend, which is Edi Zuhairi, Muhammad, and also Irfan. Okay, for this slide, I will briefly explain the FKMP biodiesel plan at UTHM. So the plan was introduced to help students understand on how plant-based oil and used cooking oil can be converted into usable biodiesel. So it is designed as a learning facility where students can gain fundamental knowledge of the biodiesel production process while also experiencing hands-on practical exposure. So during our visit, we were introduced to the main components and system involved in transforming used oil into biodiesel. So during our visit, uh, it allows us to visualize and relate thermodynamics concepts such as heat transfer, energy conversion, and system efficiency that we learn in class to real industrial application. Okay, so this slide shows the background information on biodiesel. Biodiesel is a renewable food that is produced from biological sources such as used cooking oil, animal fat, and also vegetable oil. Okay. It is commonly used as a cleaner alternative to conventional petroleum diesel as it helps to reduce our dependence on non-renewable fossil fuels. Okay. Biodiesel also supports sustainability by recycling waste oils that would otherwise cause environmental pollution. Okay. So overall, the use of biodiesel promotes cleaner energy, helps reduce the carbon footprint and friendly energy system. Okay, so the plant offers a rather complete setup for producing biodiesel from scratch, starting from raw materials until the final product. So it is equipped with key components such as storage tanks, reactor vessels, pumps, piping networks, main control room, and also separation equipment. So these facilities allows students to observe and understand how each system operates together in the biodiesel production process. So overall, the plant functions as an effective learning platform where students can apply theoretical knowledge from lectures to real industrial system.
Equipment and processes. There are four main equipments in this plant, which is firstly reactor, secondly heat exchanger, third distillation unit, and fourth the storage tank. So the function of the reactor is to mix oil, methanol, and catalyst to produce biodiesel and glycerin. The overall contribution in this process for this equipment is it provides the chemical reaction stage where biodiesel is formed. For the heat exchanger, the function is transfer heat between fluids to maintain reaction temperature. The contribution is it saves energy and stabilize process condition for consistent biodiesel production. For the distillation unit, it separates methanol from biodiesel and remove impurities. The contribution to the overall process is purifies biodiesel and recycles methanol for use, improving efficiency. The function of storage tank is to store raw materials such as methanol, oil, and finished biodiesel. The contribution is to ensure safe handling, continuous supply of feedstock, and secure storage of product. Now, I will explain about the main function for this equipment, which is firstly reactor. It is the vessel where oil, methanol, and catalyst are mixed, and this is where the chemical reaction takes place to produce biodiesel and glycerin. This component is the most important in this process because it is where the reaction takes place. Heat exchanger is a specialized piece of equipment designed to transfer thermal energy or heat between two or more fluids. Crucially, these fluids are usually separated by a solid wall so that they never actually mix, but the heat moves from the hotter fluid to the cooler one. The working principle of this component is it naturally moves from hot to cold. The exchanger uses this principle to either cool down a processed fluid or heat up a cold one. In industrial processes, keeping a fluid at a precise temperature is vital for safety and product quality. It can also cut costs by recycling heat. They can lower their fuel and energy bills. Distillation unit. This unit acts as a primary separation stage where we remove methanol from the biodiesel mixture. It is the polishing phase that ensures our final product is high quality fuel. Distillation works by heating the mixture since methanol has a much lower boiling point than biodiesel. It evaporates first, allowing us to capture it separately. The methanol turns into vapor, rises through the unit, and is then cooled back into a liquid to be reused in the next batch. This process helps purify the biodiesel, removing impurities and excess reactants. By removing the methanol, the biodiesel becomes cleaner and reaches the necessary chemical standards suitable for use in engines. This isn't just about cleaning the fuel, it's also about cost efficiency as we can recover and recycle the methanol for future production. Lastly, we have our storage tanks. These are vital for the logistics of the plant. We use this vessel to store both our raw materials, such as vegetable oils or fats, and the finished biodiesel. Strategic storage ensures safe containment of chemicals and provides a buffer that allows for the smooth operation of the production process. By having adequate storage, we can keep the plant running continuously even if there are delays in shipping or raw material delivery.
Hi, my name is Muhammad Irfan. I'm going to present about thermodynamic application. First law of thermodynamics is applied to perform an energy balance between heat input, output, and reaction heat. It helps to maintain the reaction temperature for biodiesel production. Second, second law of thermodynamics is applied to minimize energy losses during biodiesel production. From there, From there, will enhance plant efficiency. Third, enthalpy and entropy determine the feasibility, efficiency, and energy losses of the biodiesel production process. Safety and environmental consideration. Biodiesel production is safer and cleaner than fossil fuels, but it, it still requires careful attention. Workers must be protected from chemicals like methanol and catalysts by using safety equipment and proper handling procedures. At the same time, biodiesel help the environment by reducing greenhouse gas emission and being biodegradable. However, large-scale production can affect land use and food supply if feedstock are not managed responsibly. Safety measures. Personal protective equipment (PPE). Workers must use chemical resistant gloves, Google face shield, and respirators when handling methanol and catalysts. Emergency preparedness. Plan keep eye wash station, fire extinguisher, containment kits, and neutralizing agents. Third, process safety. Proper ventilation, closed system, and monitoring instrument reduce risk of methanol vapor exposure and fire hazards. Fourth, training and protocols. Operators are trained in handling hazardous chemical, emergency responses, and safe storage practice. Environmental impact. Lower emissions. Biodiesel reduce greenhouse gas emission compared to fossil diesel, cutting CO2 and particulate matter. Biodegradability. Biodiesel is more biodegradable than petroleum diesel, lowering risk of long-term soil and water contamination. Feed, Feedstock concern. Large-scale biodiesel can compete with food crops, leading to land use chi- t- sorry, leading to land use change and deforestation if not managed sustainably. Waste management. Methanol recovery and glycerines byproducts must be handled carefully to avoid environmental pollution.
Okay, so for the last one, challenges in biodiesel production. Feedstock availability. Reliance on edible oil raises sustainability and food security concerns. This is because biodiesel production uses oil, and we also uses oil in our daily life. So the competition between these two will increase demand uh, on edible oil. Secondly, energy intensity. Conventional biodiesel processes requires high energy input for heating and distillation. This means that more coal or more fuel needs to be burned in order to create new fuel. This is less convenient because the output is often smaller in amount than the input. Third one is safety risk. Methanol is toxic and flammable, posing hazard during storage and handling. And lastly, economic viability. Production costs can be higher than fossil fuels, limiting competitiveness. This is true because creating biodiesel requires a lot of material and also high amount of energy. So it tend to be higher in price than other fossil fuels such as ordinary ordinary diesel. So as for the innovations, we can use alternative feedstocks, which is we use cooking oil, waste cooking oil, algae, non-edible oil to reduce the reliance on food crops. This solves the problem of the the threat in food security for humans. Secondly, uses green catalysts. Heterogeneous catalysts from natural material such as dolomite eggshells can improve sustainability and reduce chemical waste. And lastly, process optimization. We can use heat integration, advanced distillation, and automation lower energy consumption to improve efficiency and reduces the amount of heat or energy needed in order to produce biodiesel. As for the conclusion, thermodynamics plays a crucial role in the production of biodiesel. The concept of enthalpy, entropy, and heat transfer enable better functioning of the reactors. The concept of thermodynamics make it possible to produce biodiesel in safe, economic, and sustainable ways. Thank you.